Hey, good morning, everybody. So today I'll present our 2Chi paper, which is called Towards Accessibility Report Generation for Mobile Apps. And this is some work I did with the help of many co-authors at Apple over the last few years. And just so you know, in the program, the PDF is linked in the comment section. There was an issue getting the link into the program. So check in the comments if you want to read the paper. Testing for accessibility is a key task in app development. So to test for accessibility issues, developers can use automated tools like linters or accessibility scanners to find issues in their apps. And over the course of this research, we talked to a lot of developers and formative studies, and we discovered a lot of problems with current accessibility testing tools. One example is that some tools only allow developers to scan individual screens at a time and clear out the results after every run, which limits them from seeing an overall picture of the app or being able to summarize what the issues are. And they also tend to have a lot of false positives, which makes the results quite noisy. Too many apps do still have accessibility issues across app ecosystems. There's been a lot of studies that show inaccessibility is still a problem in mobile apps. So what if we could have a system that could generate a report to help developers discover issues across their app without any tedious manual intervention? So why would we want such a report? Accessibility scanners can help developers to find issues, but they often lack the capabilities to summarize issues across the app. And also, if developers or QA testers are testing their app for the first time, they can't really prioritize or report on which issues to fix. And it's also very time-consuming to manually audit individual screens. But generating a report is challenging. So first, for the application, we have to identify what the issues are that we can find on each screen, and then compile them into some sort of comprehensible report. In this work, we apply machine learning to this problem using an app crawler, and we also use Xcode's accessibility inspector and pixel-based UI understanding models like you saw in the last session. And we train those on large data sets of app screens. So let's see how. Our system has two main stages. The first is capturing screenshots and accessibility audits on each screen using an automated app crawler, or you can also use a recording tool. And then those accessibility audits come from a standard accessibility inspection tool, which is in Xcode, and then that outputs a JSON file of all of the detected issues. For example, those could be things like missing accessibility labels, or if UI elements don't support dynamic type and others. The data collection will then often result in multiple audits captured for the same screen in different states or with different data. And especially in the cases where we use an automated app crawler to navigate around the app and collect data for us. So in the deduplication stage, we use a screen grouping similarity model that we trained for this work to group reports for different instances of the same screen together. So let's see how that model works. To train the screen grouping model, we collected a large data set of annotations for both iPhone and iPad applications with over 200,000 screens, and then we had human annotators using this graph sort of card sorting interface to group the same screen instances together, like you see here. And after that, we trained a screen similarity transformer model where the input is two screens, and then we can either produce a binary prediction, we can also produce an embedding, which lets us compute screen similarity across the application to determine the similarity of two screens. And this model performed quite well, achieving around 90% F1 score on this data set. And we use the screen grouping model to generate these app storyboards that you can that group together different instances of the same screen. And as you can see, our model tolerates some significant differences in the screens. For example, the group showing a different watch face in the center that I'm zooming in on here. And after deduplication, we want to have a summary of the unique issues only. So then within each of the screen groups, we do issue deduplication, which takes the bounding box of the issues that were detected by the accessibility inspector and maps them to elements that were detected by the UI object detection model. And then we apply some heuristics and template matching computer vision algorithms to locate corresponding elements across screens. And in this case, it performs quite well. with even working pretty well on screens that are scrolled down slightly or have other content changes. And once we have the set of unique issues for each group of screens identified, we generate this interactive HTML report as the output of our system. And in the report, we group the issues together to make the information easier to digest, such as categories for like large text or labels. And then we provide this simple summary that lets users inspect issues across the app to see where all the screens that have dynamic type support is missing, for example. And then we evaluated 3 research questions on this system to study how developers and QA testers interact with these reports, how they use them to summarize and interpret issues, how they can support these users in prioritizing and finding the issues quickly, and understanding how these reports can be used to fit into the workflows of the participants. And we evaluated the system with a group of non-beginner accessibility QA testers and engineers across Apple, where we compared different methods of capturing accessibility reports. And for the task, the participants went through a couple of apps within a short time frame to basically compile a quick list of key issues that they could find in those apps using both manual testing and our tool. And this is a very common exercise that they go through all the time, especially the accessibility QA people. And then they actually used 3 variations of the tool. One was single screen scanning, where they could only look at one screen at a time. And then they also used multi-screen mode, where they keep, it allows them to keep the results for multiple screens and kind of go through the app manually to get a report they create themselves. And the app crawler mode produced the report from the app crawler before the study, and then they could also use their manual testing. And through this, after this study, we found that the participants did prefer the app crawler or the AC report most compared to other tools for the report generation, and noted lots of different benefits it gave them over the other tools, such as being more shareable, like they could send it around to other developers or QA testers to share it with people, and then also get a more holistic overview of the app in the same amount of time. Reduces them a lot, saves them a lot of manual effort. And another thing was it reduced friction in context switching, because they could just have the report versus going back and auditing and then looking at the report, and it would cause them to lose context there and not really get a good look at the whole app. And finally, for some of the QA testers, they no longer needed to use Xcode, which is where the other tool is, so they could have this report outside of the heavyweight development environment. And the participants are more satisfied overall as well with their accessibility audits and lists that they created of summarizing the issues, and they found real issues with those, such as things like a lot of missing accessibility labels and major contrast issues in those apps, or even like some of the apps completely didn't implement the dynamic type feature. And the participants were also more able to find more important and high-level issues that kind of summarize it across the app. And we think that's because the report gives them the ability to find orders of magnitude more issues in the same amount of time. Automated accessibility reports provided by the app crawler also helped participants to more quickly discover issues, such as this participant, which was mentioning it was a real bottleneck to keep loading the screens and running the tool on each of the views. The participants also noted the automatic report helped them to more easily prioritize which issues to fix more immediately or to take a look at versus some of the lesser priority issues. And one participant said it was a great delivery to be able to quickly see an overview across the app which screens don't support dynamic type, and thought that was such a great delivery. And there are some limitations in our system, of course. One limitation in the system the participants found is that the number of issues that could be reported by the tool becomes overwhelming. So if you have a high number of issues, maybe even hundreds of issues for some of these apps that we use in a study, And we also collected participants' ideas for how to better prioritize the issues, to help them pull out the salient ones for future iterations of this tool. And participants had a lot of great ideas for this. They mentioned things like emphasizing the impact of the issues on the end users through statistics, like how many people might be impacted if this accessibility feature doesn't have good support. Another was by the amount of use or the scope of the issue across the app, or even importance of the UI element in different navigation flows. And then also by severity of the issue, where we just have some predefined categories, like these issues are slightly more, maybe a button that's like slightly too small, target size might be less important than if you're missing accessibility labels across the whole app, for example. And we also uncovered some findings about future workflows for accessibility reports, such as using this report over time to compare and to track the accessibility issues that are coming up, and using this in a continuous integration pipeline for very large applications can help people keep track of issues that are popping up between the test passes that they're doing when they go through and do their accessibility testing. And for developers, one of the things they noted is that the report still was too much friction for them in being separated from their IDE, which was a benefit for the QA testers. So they would like this sort of functionality to be closer to the IDE where they develop their apps. So lots of future areas of improvement. And then one step towards reducing this distance, we actually released a feature on this in Xcode. And that feature lets developers use the accessibility inspector to get this interactive HTML report across multiple platforms, including iOS, tvOS, Mac, and Watch. So that was exciting. And to summarize the talk, we found that accessibility reports can help support developers in reducing and finding reducing the effort in finding issues, discovering patterns of inaccessibility across their apps, and prioritizing which to fix. And also integrating these reports can be helpful for them to have some new capabilities, like continuously tracking the issues over time and things like that. And then lastly, the machine learning approach that we use in this work can help report issues even on highly inaccessible apps, which have little to no view hierarchy, which is also a key differentiator from prior work, which relies heavily on view hierarchies, which may not be available in some of the worst-case inaccessible apps. So thanks for attending the talk, and please take a look at the paper, and happy to take any questions.
Ming-Yuan Zhong from the University of Washington, and thank you, Amanda, for the awesome talk. And I really like 2 points in this talk. One is the understanding of like the reuse of UI components across apps. So this really simplifies things. And the other is, we still need better developer support to fix these. So do you foresee any potential future work on this so that it's easier for developers to just directly fix these issues rather than look at a really long report?
Yes, yeah, totally. That's something we're definitely looking into. I think there's because of all these new models, LLMs, whatever, code generation models, these types of things, we can move some of this into the IDE as they're developing their apps. That's I think my goal was always to bring this much closer to the source of where these issues are popping up, and do as much as we can in the IDE for developers. And I think also at the same time we need this sort of report for QA who don't work in developer tools. So both directions are super valuable.
Right. Yeah, that's super valuable. Thank you so much.
Yeah, thank you.